Hey everyone, and welcome. Today we are diving into something that's, well, at the very heart of C programming, conditional statements. This is how you give your code a brain. Seriously, it's how you let it make choices, react to different situations, and solve actual real-world problems. So let's get right into it. So think about it. At its core, programming is all about problem solving. But how does a computer actually know when to go down path A instead of path B? How does it decide what to do when the data changes? That is the fundamental question we're going to answer today. And you know what? It's all based on a really simple logic that you and I use every single day. You check a condition, hey, is it raining outside? And based on that answer, you do something. That exact if this, then that thinking is precisely how we're going to teach our programs to think. Okay, let's start with the most basic, most fundamental decision-making tool in our entire C toolkit, the simple if statement. The best way to think of it? It's like a gatekeeper for your code. Now, here's a classic exam question. Your professor will almost definitely ask you something like this. And it's the perfect job for our first tool. All we care about is one single thing. Is the number bigger than 0? If it is, we do something. If it's not, we just do nothing. So, here's the absolute key detail you have to understand about C. The if statement looks at the condition in the parentheses and asks, is this true? Now, in the world of C, true just means not 0. Seriously, any number that isn't 0 is considered true. Only 0 itself is false. So if the condition is true, the code inside the curly braces runs. If it's false, the program just skips right over it and keeps on going. And would you look at that? This really shows you the power of that simple logic. The code is just so clean. If number greater than 0. That's all it takes. It's easy to read, it's direct, and it tells the computer exactly what to do and when. That kind of simplicity is what makes for really great, effective code. But, what if doing nothing just isn't an option? A lot of times, a decision isn't just do this or do nothing. It's more like do this or do that instead. And for that, we're going to need a different tool. Let's think about another classic exam problem. Is a number even or odd? I mean, there's no third option, right? It's one or the other. A simple if just isn't enough here, because we always have to give an answer for both of those possibilities. And that, my friends, is where if-else shines. It literally creates a fork in the road for your code. If the condition is true, boom, the if block runs. But if it's false, the program doesn't just move on. No, it jumps straight to the else block and runs that code instead. It forces a choice. It's got to be this or it's got to be that. Awesome. So we can handle one possibility. We can handle two. But let's be real, the world is usually a lot more complicated than that. What happens when you've got 3, 4, maybe even 10 different paths your code could take? This exam question is a perfect example of what I'm talking about. A number isn't just positive or not positive. It can be positive, it can be negative, or it can be 0. That's 3 totally separate conditions we have to account for. You can think of the if, else structure kind of like a waterfall. The program starts at the very top, checking that first if condition. If it's false, the logic just flows down to the next else if. It keeps on flowing down this chain until, bam, one of the conditions is true. The second it finds a true one, it runs that code and then jumps out of the waterfall completely. And that final else at the bottom, that's the pool that catches everything that didn't match any of the conditions above it. Now, if-else if is super powerful, but it can get a little messy if all you're doing is checking one variable against a long list of specific numbers. Like, imagine a user is choosing option 1, 2, 3, or 4 from a menu. Writing all those else-if statements would be so tedious, right? Well, there's a much cleaner tool for that exact job. And here it is, the switch statement. It was practically born for this scenario. You give it one variable, and it just jumps directly to the case that perfectly matches that variable's value. Honestly, for these kinds of is it equal to this checks, it's often way more readable and sometimes even faster than a long chain of if-else ifs. But, and this is a big but, with switch there is one critical detail you absolutely cannot forget: the break keyword. Break is like a stop sign. It tells the program, okay, we found our match, job's done, get out of the switch statement now. If you forget it, you get this crazy domino effect. Your code will run the right case and then just keep on going, running every single case below it. This is a classic bug called fall through, and trust me, it could be a nightmare to find. Okay, so now we have our toolkit. We've got if else if, and switch. The real secret to mastering this stuff isn't just knowing what they do, it's knowing exactly which tool to grab for which job. So let's put them head to head. This table really breaks it all down. Think of the if-else chain as your all-purpose Swiss Army knife. It can handle any kind of condition you throw at it. Greater than, less than, complex stuff with ands and ors, it's super flexible. Switch, on the other hand, is more like a specialized tool, like a socket wrench. It's built for one job and one job only, checking if a variable is equal to a specific value from a list. And in those situations, it is so much cleaner and easier to read than a giant if chain. Knowing the tools is step one. Step two is learning how to avoid the common mistakes that, well, pretty much everyone makes when they're starting out. Let's walk through them so you can sidestep these classic blunders. First up, the legendary equals versus equals equals bug. Look, a single equal sign assigns a value, and a double equal sign compares two values. Mixing them up is basically a rite of passage for every C programmer. Next, forgetting your curly braces. Here's the rule. If your if or else block has more than one line of code, you must wrap it in braces. And finally, the one we just talked about, the missing break in a switch statement, which causes that wild, unpredictable fall through. Keep an eye out for these three, and your code will thank you for it. So let's boil this all down into a quick little mental checklist. If you just have a single, simple check, a gate to pass through, use a plain if. If you hit a fork in the road with only two paths, that's a job for if-else. If you're checking against a bunch of different ranges, like on a ruler, the if-else-if chain is your friend. If you're picking from a list of specific options, like from a vending machine, switch is almost always cleaner. And if your logic is layered inside other logic, like Russian nesting dolls, then you can nest your if statements. And that brings us to our final challenge for you. It's your turn to think like a programmer. Let's say you're building a discount system for an e-commerce site. You've got to deal with different price ranges, customer tiers like gold or silver, and maybe even specific holiday promo codes. Which conditional structure would you reach for, and why? Just so you know, there might be more than one right way to do it. Think about that, and thanks for joining me today.